This is B&O Railroad's 1870 Great Stone Viaduct. I'm Darren, and this is the Industrial Revolution. As the 1800s progressed, B&O Railroad had a problem. They had new markets developing west of here, especially Chicago and the port of Sandusky up on Lake Erie. And they didn't really have a great way to move between those far western markets, now considered Midwest, of course, and the East Coast. B&O did have one good river crossing south of here. Unfortunately, it's about 90 miles downriver in Parkersburg, West Virginia. But that was a long ways out of your way. So to cross here, where they had rail lines, they'd actually have to unload everything from the train onto ferries, cross over the Ohio River, load it back onto trains, and then head east onto the East Coast.
Now, don't get me wrong, the ferry service did, in fact, work. It was very profitable from the point of view of the ferry owners. That, of course, means it was very expensive from the point of view of the railroads. Rather than accepting their fate, in a move reminiscent of the last decade or so of lawsuits over the Gordie Howe Bridge crossing the Detroit River today, the ferry owners sued B&O Railroad to stop its construction. Despite receiving an initial court injunction to block construction, the case eventually went all the way to the Supreme Court, with B&O proving victorious, and the construction was allowed to continue. The entire crossing was designed by Jacob Linville of the Keystone Bridge Company, which also provided all the wrought iron truss work for the bridge and the much shorter West Virginia approach sections. Consisting of three parts, the Great Stone Viaduct on the Ohio side, the bridge over the river itself, and the stone piers and trusses on the West Virginia side, the total span is 8,566 feet, or about 1.6 miles or 2.6 kilometers long. The viaduct itself uses 14,854 cubic yards, or 11,357 cubic meters of sandstone, weighing an estimated 29,000 tons. Add in another 25,375 cubic yards, 19,400 cubic meters, or 49,000 tons of sandstone, for the bridge piers and the approach on the West Virginia side. That's a total, just across the river here, of 40,299 cubic yards, 30,811 cubic meters of stone, weighing around 78,000 tons, or just about the same as the entire Washington Monument. Pictures are impressive, but to really understand just how long this viaduct is, you really need to walk its length. Now, if you're thinking, like I was, that these numbers must be wrong, that surely the incredibly long stone viaduct must weigh more than the much smaller piers and abutments, well, there's one other fact to consider. The Great Stone Viaduct is actually hollow. Okay, it's not exactly hollow, but after the stonework was built for the arches, and then the sidewalls were built, the center area above the arches and between those sidewalls was actually filled with smaller stones, gravel, etc. And this actually served several purposes. First, it was cheap. No stonemasons, no shipping the huge amounts of stone from the quarries, etc. Secondly, it was fast and using unskilled labor. You just had to dig up the dirt and dump it there. And third, this actually helped the viaduct and the trains as well, since the gravel actually absorbed the vibration much better than if the entire structure had been built out of solid stone. Along its length, there are 43 stone arches, each one 33 feet 4 inches wide and between 10 and 12 feet tall. To begin building them, you first start by erecting large wooden scaffolds for each arch. These will hold the stones when you come back to build later. The arches themselves are actually all the same height, but they do have vertical supports that the ends of the arches sit on, and those actually range from nothing up to 10 feet tall. And that gives you the height that you need for the arch as you approach the river. Anyway, once you have the scaffold built, you begin laying the stones onto the scaffolding. In this case, each side of each arch was actually made up of 37 stones. You have 18 on each side plus the keystone. And that is not a random number. 37 was chosen specifically to represent the 37 states in the country when the Great Stone Viaduct was built. Once the arches are built, then masons build up the remaining sidewalls, and workers fill and pack the space in between. Across the river in West Virginia, construction was actually completely different. Simple stone piers were constructed with wrought iron trusses spanning the space between them. You can see that not all these piers have done well over the last century and a half, with some repairs needed due to both weathering and, I suspect, heavy truck traffic around them. This side of the river is a pretty heavy industrial area. The other side also has a little wear and tear on some of the piers where cars are allowed to drive next to them. The same process was used in the river with 6 large stone piers and wrought iron trusses. It's worth noting that each of these piers in the river was equipped with a special feature called an icebreaker on the upstream side. This breaks up pieces of ice floating down the river instead of allowing them to jam up against the bridge itself. This both protects the bridge from damage from the ice, but also these ice dams can become quite dangerous, leading to flooding upriver and, when they finally fail, flash flooding downriver. So have you ever looked at one of these huge stone constructions and noticed all these little holes in it? Like here, and here, and here, and here. I wondered, what are those things? And also, why is this shaped the way it is? Well, it's pretty easy. The holes are actually blasting holes. These were, when they were doing the quarrying of the stone originally, they would drill in, and then depending on when it was, either put in dynamite or TNT or black powder or just about anything else, depending on when you're looking at, and you'd blast. But you usually dig a little bit further than you really had to. And that's why you often wind up with like an extra inch or two, like in these. They just go in like an inch or two. They don't really hurt the stone. And as for this surface, today you pay extra to get this kind of surface. I know I've been buying some stone lately for a historical restoration site that I've been helping out with. But originally this is just how it kind of blasted off the walls. You cared about this surface here, any surface that's going to mate onto another stone, but the faces here, you didn't care what those looked like so much. And that's why these, for constructions like bridges and tunnels and stuff, they're often rough and texture like this. And that's really nothing to worry about either. It's just the way it blasted apart when they did the original blasting. As for the dark coloration you see on most of these old structures, this is the natural color of this stone here. This really light tan. This is a very light sandstone. And yet, as you look around through the structures, and a lot of older structures, you see a lot of them have turned completely black. And why is that? Is that aging? Is that like, copper that turns green as it ages? No. The black on this, purely air pollution. The first train crossed here on June 21st, 1871, and traffic continued on like that until about 1900, when B&O decided they needed to add a steel approach trestle from the north. This new steel approach merged into the Great Stone Viaduct just about halfway down its length. The steel trestle is about the same length as the stonework of the Great Stone Viaduct, but by 1900, metalworking had improved to the point that steel was much preferred for this approach as opposed to building another stone viaduct here. Today, you can walk along the original approach to the viaduct, following the original rail line, past the stone retaining wall, and then walk out onto the viaduct itself. As you do, while you're walking along this massive stone construction, it's hard not to think of all the work that went into it. The masons working here, fitting together a ridiculous number of stones, tens of thousands of tons of sandstone to build this structure. The workmen following behind them, filling in the space above the arches and between the walls with leftover stone that the masons had cut off, plus gravel that they dug up locally. You think of all the trains that crossed here. Steam trains at first, then later diesel electrics, carrying really everything from iron and coal to produce and passengers. Just an incredible amount of history came across this viaduct.
In 1996, CSX Railroad, just the owner then of the Great Stone Viaduct, abandoned about half of it. They still use the steel bridge, the steel trestle. They still use the bridge across the Ohio River, but the part of the Great Stone Viaduct headed south from the river was shut down and abandoned. It stayed abandoned until about 2016, when the Great Stone Viaduct Historical Education Society was formed to preserve and present and turn this into a park. And it opened in October 2022. Today, you can walk the full length of the viaduct. On the bottom, you can walk almost up to the closed section here on top. And just beyond here, you can see what the original top looked like when it was closed. We still have the tracks in place. Now, the theatrical side of me was really hoping that my conclusion here would have a train coming across the bridge just as I finished up the video. And it didn't happen. I've been out here for 2 hours, freezing, and no sign of a train. I asked a couple of local people how often they come by, and the answer was not very often anymore. Well, the Great Stone Viaduct used to be a critical way for goods and people to cross the Ohio River here. It connected Chicago to New York and allowed for far better, far easier, far cheaper transportation. And even though today it's not in use so much, still, this viaduct is the Industrial Revolution. Hey, wait, don't go yet. Don't go. I need some help. To keep this channel growing, I really do need you to help out. And the easiest way you can do that is just to like this video. Just hit like on YouTube, and that tells YouTube that this video is worth watching. You can also subscribe and hit notify. That'll tell YouTube the whole channel is worth watching. And you'll see this pop up in your feed when you go into YouTube, so you can watch my new videos when they come out. I also have a Patreon page over at patreon.com/Industrial Revolution. So you can go help out over there. That'd be great, just a few bucks a month. And thanks for stopping and watching this video, and I look forward to seeing you for the next one.